I'm Kyle.
I'm Josh, and that's Mom and Dad. We are the Royer family.
In this video, I'm gonna invent the Kyle Eugene Royer latch, version 1 and version 2, otherwise known as the Kerr latch.
But before we do that, consider signing up for our free 1 hour forging segment where Kyle teaches you how to forge out an everyday carry blade. This video is made for the beginner bladesmith, so sign up now, link in the description.
This is a very complicated handle with a bunch of pieces that all need to go together. And I don't want to have any external pins that hold them all together in the finished product. The majority of the handle is going to be screwed together with little tiny 80 screws. But there's a problem. One of the scales cannot be screwed on because we would have external screws and there's no way to really make them hidden. So what I'm going to do is a really cool latching system for one side of the handle scale. And what we're going to do is mill in a couple of slots, and then we're going to weld in a couple of pins that go across each slot. And then the other piece, which will be the metal piece on the outside that has the mother of pearl in the center, it's gonna have a couple little hooks sticking up. The way this will work is these little hooks right here will hook onto these pins that go across. So you just put it together and then slide it down and it snaps right into place. So I'm super excited about this. I've never done any kind of construction like this. I really want to make this work because it's really fun and exciting to try to make new mechanisms and try to come up with a little bit different ways of doing things. I've got my little layout marks I made with that super small drill bit and my pattern. Next thing we need to do is chuck this thing up in the mill and start doing lots of milling to make each one of those little recessed hook slots.
Kyle takes a really fine stone to his vise so he knows for sure whatever he puts on it will be flat.
I finished milling all the slots in what's gonna be our frame for the handle, and those slots are gonna be part of the hook system that hook in the scale on one side, and then the other side will be screwed on. Next thing we need to do is start working on the other piece that's gonna hook onto it. We need to use this as a pattern. It's got holes going all the way through, right where those hooks go. So I'm gonna line it up on this mild steel piece, and we'll clamp it on there and then use those holes that are already there and drill those into this piece, and that's where our little hooks will go. Once the pins are in the scale piece, we're going to argentium silver braze them in, or hot solder, and it's a really high temperature solder that's super strong. We'll have to heat the piece up to about 1500 degrees to get the solder to melt. But like I said, it's really strong. I did a test piece earlier where I was pulling on it with vice grips and the pin broke off before the solder let loose. Now that we have our super cool latching system figured out for one side, it's time to start working on the other side. So I'm gonna take the frame piece that already has lineup pinholes in it, and we're gonna line it up on a brand new piece of mild steel for the other side of the handle. And we're gonna clamp it on there and then start drilling some little lineup pinholes. I need to make sure those don't go very deep though, because I don't want them to end up showing up on the outside of the handle. So I've got my little 16th inch drill bit, put a little tiny mark on it for where I need to stop as far as the depth goes, and that'll be good for the lineup pin holes. Once we get the lineup pins into the piece, then we can move on to little tiny 80 screws. And when I say little tiny, I mean tiny. These things are so small and cute. We're gonna have 6 of these screws holding this frame to the other handle scale. I've got 6 little center punched marks ready to go in the pattern. We're gonna drill those out and then we'll use the pattern to locate those holes into the frame. And we'll drill through the frame and into the window frame piece. For these 80 screws, the threaded part needs to be a 3/64 drill bit. And then we're gonna use a drill bit for the unthreaded part of the shank that's just under 1/16 inch. And the heads on these come 1/8 inch diameter. But I think I'm gonna turn the heads down smaller because we don't need all that extra material on the head, and that'll allow me to make this a little bit smaller profile because I'm getting these screws really close to the edge of the handle. So if I can make the head smaller, I can countersink it smaller and everything. So I'll make the heads 3/32 of an inch instead of 1/8. We got our center frame piece and our outside pieces that'll be blued steel with a cutout of mother of pearl in the centers.
Pause. You may notice audio quality went down. That's because someone forgot to hit record on the recorder. Play.
I am super happy with this thing. It's 3 pieces that are all mechanically held together, but you don't see any screws or anything externally that would let you know that they're held together. After all that machining and fitting and threading and tapping and cutting and filing, it is finally time to start cutting the frame in half. So I took the frame, I lined it up on here as best as I could, basing it off of this front spacer, clamped it in place, and then scribed around the tang so it could leave an outline onto the frame piece. Now I need to take it over to the bandsaw, cut it out, and then clean it up on the grinder and get these pieces to fit on here. I think before we do that though, we need a good luck coffee break because this is kind of where the rubber meets the road here. Coffee break. Whew, that was the bottom of the cup, definitely a little cool. And I don't normally guzzle it, but it's good still.
The piece Kyle is working on right now is the same Damascus as the blade. If he messes up on it, it will be nearly impossible to duplicate the exact pattern again.
This is starting to get exciting. We actually have a handle assembly that slides onto the knife blade. We've got a really nice fit here. There's no wobble in it this way at all, and it seems to be fitting up really tightly to the front spacer already, so I think I've got good angles and stuff on here. I think we'll get the end of the handle cut off to the right length and start getting that flattened and start working with our Damascus pommel piece. Start drilling holes and stuff in that, and we can also start thinking about making the pommel nut and getting the tang threaded and all that stuff down here on this end of the handle.
Kyle wanted a sneak peek of the Damascus from the pommel, so he stuck it in ferric chloride so he could see the pattern.
All the components are coming together nicely. We've got the pommel with the hole for the pommel nut drilled in it and a little countersunk area that the pommel nut can kind of rest in. That'll allow us to have a really nice pommel nut fit and still dome the end of the pommel completely without having to leave any kind of flat spot on there. The next thing we need to do is get this tang shaped down and threaded.
Pause. Okay, I noticed the audio wasn't recording at this time, so I went ahead and hit the big red button. And so now it's recording. Yay, good audio. Woohoo. Play.
In order to get these layout lines for the threaded portion of the tang, I used the pattern. So I took the pattern, lined it up on there, I found the center of it, and then I went just above center about 1/16 of an inch, because it always looks good to have your pommel nut above center or in the very center, but it looks horrible if it's below center. And then once I established my mark where I wanted the very center of the pommel nut to come out, I just transferred that mark over onto the tang, and then took the pattern off and just put my square on the end of the handle, because the end of the handle is already pretty much shaped the way I want it, so I can put my square on here and get a nice long straight line to go by. After that, all I had to do was take the machinist square and make a mark on each side of the line 1.5/16 out, and that leaves us with a 3/16 inch scribe line on each side of our center line. And that way, once we get all this ground and threaded and everything, it'll be nice and square with the end of the handle. That's very important, because we need the pommel nut to go in nice and straight and not be all canted one way or the other. I'm gonna rough this in with a 36 grit belt, and then we'll fine tune it and clean it up with a 120. I want to draw the temper back on the tang all the way down into the ricasso. So I want to heat the tang up to like a blue color, and then while we're at it, we need to soften, like completely soften the very end of the tang that needs threaded. The colors aren't real pretty because I didn't clean the tang, so it's got oils and stuff on there. That's why the colors look so dirty. I put a lot of extra heat down here at the ricasso because it's a lot more metal to heat up there. Now we're getting a nice blue color. I'm gonna bring that glowing color just past where we're doing the threads, just so it's not causing a weak spot right there where it meets the main portion of the tang. We just wanna heat it up till it's lightly glowing a little bit, just like that. We're gonna let it air cool, clean it up on the Scotch-Brite wheel, and then we can start threading it.
Once Kyle cuts the threads in, he starts working on the pommel nut.
We've got our entire handle assembly to where we can put it together and take it apart, but we still need to put lineup pins on the front and on the pommel end just to make sure that everything lines up exactly the same every time we put it together and take it apart. The next thing we're gonna do is super glue the front spacer to the front of the handle, and then we can take it over and mount it up in the milling machine and transfer those holes in the front spacer into the front of the handle itself. Then we'll be able to put pins in there and have it all line up the same every time. Starbond sent us some super glue, and I really like especially the thick super glue for what I'm about to do because it doesn't run all over the place and make a huge mess. The thin super glue might hold better because it'll run between the parts and cover more surface area. In this case though, I don't need it to stick really well. I just need to hold the part in place long enough to drill those pinholes, and then we're gonna knock it loose. So for that purpose, the Starbond thick super glue works really well. If you guys are interested in getting some Starbond super glue, then check out the link in the description. I'm just gonna put a small bead all the way around and then spray some of the accelerant everywhere we have super glue there. I'll let it dry for a minute because the accelerant will just set up anything it touches. So the inside of the super glue is still gonna be a little bit wet, so we need to let it dry for a minute, especially because I put it on a little bit thick in a couple places. That should hold our part in place and we can drill those holes. Now we have those holes, we'll mount it up in the mill and drill those holes into the front of the handle. Before we drill, there's one more thing I need to do. I need to set the depth. So I'm gonna run the drill bit all the way down to the bottom of the hole, lock my spindle in place, so now the drill bit's touching the front of the handle, and then I can kind of come in here and put a mark on my drill bit. I think I want to go into the front of the handle about a 1/4 inch, so I just put a mark about a 1/4 inch up. Now we can stop at that mark and get somewhat the same depth in each hole. That was a mistake. I might not get that out of there. Pin's not turning. Oh my goodness. 20 minutes later. So the last thing you saw, I had a problem. I went to pull out my pin that we just got in the end of the handle, and it was completely stuck. My hole was a little bit too undersized. I clamped it up in the vise and I had to pull on it really hard, and eventually the pin just broke off. But thankfully there was a little tiny shard sticking out. I took the torch, heated this area up to just barely glowing, and then I could get that little tiny shard, I could clamp onto it just a little bit, and with it heated up, I was able to wiggle a little bit and pull out that piece of pin, save the day. After heating that metal with the pin stuck in it, I had to lightly surface it once again, and I noticed my plate with the hooks on it no longer fits as tight as I want. So we need to put a little bit more tension on those. So I think I'm gonna lightly tap on them with the hammer and just try to get them to close up a little bit. So the way I've been adjusting them is just taking this really small piece of drill bit here, it's 3/64, and just lightly hammering down on the pin. That kind of closes it back up at the front, and then I can hit back here towards the back to kind of close that up a little bit too. No! Broke off.
3 days later.
Here's what's happened so far. We were tightening these little hook pins, lightly tapping on it with a hammer, and one of them broke off. These are just made out of mild steel, so I guess after all the tightening and stuff I'd done, and then they would loosen and then tighten, eventually broke off, just like peeling a soda can pop lid thing. What do you call those? Tab, a soda can tab over and over again. It would break off eventually. That's exactly what happened here. This was pretty devastating that it happened, and it took me quite a bit of time to figure out how to fix it. But if this would have happened at the end of the project, after the gold inlay was done and the bluing, and we had the mother of pearl in there and stuff, and I'm getting ready to put the final thing together, and one of these pins broke off because I was doing a final tightening adjustment on it, that would have been absolutely devastating and may have had to completely rebuild the part and rethink everything. So I am glad and grateful in the same, trying to say them at the same time. I am pretty happy it happened when it did instead of later on in the project so I could do something about it. I still wanted to go with the same kind of latching system because I absolutely loved the way that worked and how it's gonna make it so I could have invisible pins holding the inside together. So instead of those pins, I machined out of 15N20 high carbon steel some little tiny hooks, and through those we put a screw and also a lineup pin. So I just stick a little lineup pin right here. The lineup pin keeps it from turning side to side, and the screw holds it firmly down to the piece. These little hooks are definitely the smallest machined anything I've ever done on the mill or lathe or anything like that. So they were kind of a challenge. They're so small, I can barely like hold on to them when I was like trying to deburr them and lightly sand on them and stuff. So we've got a little 80 screw that goes right down through the center of it. So once you get all 4 of those screwed on, it works exactly the same as the previous version. By the way, my name for this, I'm calling this the Kerr Latch 2.0. Kerr stands for Kyle Eugene Royer. It pops on there. Nice snap. And then you slide the piece forward. So these Kerr latches were really fun to make, and I think they provide some really nice benefits over the previous model of just the mild steel pins. I've got my original pattern over the part, and we can now scribe around the pattern and transfer that onto our knife. We're gonna take this over and bandsaw off the excess material, and then we'll start grinding. I'm gonna not quite go all the way to the line because I wanna make sure everything's looking good on the inside of the handle. So I'll get close to the line, take it apart, make sure everything's looking good, and then keep grinding from there or make adjustments.
You can see the difference between the steel. The outside pieces are mild steel and the middle is Damascus.
I finished profiling the handle and it's looking really good. It's really starting to look like a knife now. It's a little on the heavy side still, but we've got a lot of metal to remove. I spent a lot of time making sure that everything was nice and square on the top and bottom of the handle, and I also left it with a belt finish at 320 grit. Next thing we need to do is thin down these handle scales. The sides of the handle, we need to take off about 100 thousandths of an inch off of each side and get them down to about 200 thousandths of an inch thick. I got the scales thinned down to about 220 thousandths of an inch thick. We're ready to move forward. In the next video, we're gonna be starting to cut out the inlays for the mother of pearl and shaping our mother of pearl and getting that all fit up in there. Once we get that mother of pearl in both sides of the scales, we're gonna be golden. I will see you in the next video. May the forge be with you. Bye-bye.